Okay, so number 3. Prove it has symmetry about the y-axis. So first option is use negative r, negative theta. So I'm going to start with that one. So negative r, negative theta. Right? So I'm going to rewrite that just doing basic math. That's negative 4 theta. Now I have to know about how to handle sine. Sine is an odd function. So what does that mean about that negative? It comes out to the front. What happens to these two negatives?
They cancel out.
What am I left with? Exactly what I started with. Done. Done. Some of you then start babbling on and doing the second test. No. No, we need one. We need one to work. If this one didn't work, then yes, we would move on to the second one, but we only need one to work. Okay, Mary?
Yeah, I just had it was just circled on my test, so I wanted to make sure I did it right.
Can you do the second part of the equation just
No.
to show us? How
Don't need to do it, not gonna do it.
Oh, it's on the 6 homework, number 4.
If I have time, there's no more questions, Peter, I'll do extra stuff, but I wanna
Okay.
make sure I get through all the stuff. Which one am I doing?
Number 4 is the 4A, I'm sorry.
So I have negative root 3 minus I. My job is to raise that to the 4th power and answer in both complex and trigonometric. Trigonometric form is another word for polar form. The CIS, cosine, I sine, that's trigonometric form. So we want both forms. Well, some of you literally foiled this out. And that's okay. Thank God that wasn't an 8 or something. But yeah, you can absolutely foil that out. That's a foil problem. I'm going to choose to do it with the log. So that means that I have to change it in a polar form. So negative root 3, negative 1 looks like that. I recognize those numbers as you should. So this is 2 and this is 30 or pi over 6 if you're working in radians. Okay? So what's my number? Well, my radius is 2 and my argument or my angle is, nope, it's not 240, 210. All right, and now I'm going to raise that to the 4th power. This is not the answer. The answer is what I'm going to get when I raise it to the 4th power. Okay, so the law says 2 to the 4th, which is 16. And 210 times 4, which is 840, which is way too big. So that's going to have to be shrunk down to 120. And there is your answer in polar form. Now, somebody on somebody's homework, they were trying to create extra answers. Sometimes these problems have multiple answers, but when? When do they have multiple answers? When we're rooting, taking the 4th root or the square root. Are we rooting in this problem? No, there's one answer. There's one answer. And there it is in polar form. Now, what is it in complex form? Because I have to answer that way also. So I know that means I need my x and my y. This is complex rectangular Cartesian form. How do I get x? Always. R cosine theta. How do I get y? R sine theta. So I'm going to draw my 120. You might have this memorized. Some of you are getting really good at this stuff. I don't. So I'm going to draw my 120-degree angle. What's the cosine? Negative 1/2. So my x coordinate's negative 8. What's the sine? root 3 over 2, oops, root 3 over 2. So my y is 8 root 3. So what's my number? Negative 8 plus 8 root 3.
Wait, really quick. If you were to FOIL out like negatives for root 3, like the original thing,
You get that?
you would? Okay.
Yep. Now, I'm gonna caution you, because that's gonna take a lot more time, so I wouldn't do it, but
I wouldn't.
if you did, that's exactly what you would get. All right, are we done with this problem? We're done with this problem?
Yeah.
Okay, Lucy?
On the same homework, can you do 5?
Now, this one is going to have multiple answers, because in order to solve for A, we're gonna have to do what? Get rid of the 2/3, and we're gonna get rid of the 2/3 most easily by raising both sides to the 3/2 power. Because what do I do with those exponents right there?
Cancel.
Yeah, multiply them so they cancel. So A is gonna equal negative 2 root 3 plus 2i to the 3/2 power. And what does a 3/2 power mean? Square root cubed. So we're gonna get two answers here. This is a square root problem, so I'm gonna get two answers. Okay, so I'm gonna go back, go through the steps again. I need the blob. So negative 2 root 3, 2. What's this gonna be? 12 and 4 is 16, it's gonna be 4. You recognize those numbers, they're not exact, but divide them all by 2. 30, that's a 30-degree angle, yep. This is no calculator, you gotta be able to know how to do that, that's a 30-degree angle. So my number is 4 CIS 150, right, because this is my angle. And that's what I'm raising to the 3/2 power. Okay, so DeWab says 4 to the 3/2. I'll figure that out in a second. And then 150 times 3/2, which is 225. 75 times 3. Now that's my first answer. Remember, we are square rooting. So how many answers will there be? 2. And how will I find the second one? Add 180, or in this case, I might subtract 180. It doesn't make any difference. When it's 180, do you understand why it's okay to add or subtract? Can't do that with 60 or something like that, but we can do that with 180. So here, well wait, what's this mean? 4 to the 3/2. Square root of 4 cubed. Okay, so 8 CIS 225 is my first answer, and then 8 CIS 45 is my second answer. And those are wonderful, except, what form is this? Polar. What form do I want? Okay, that means I get to do what I just did. I need for both numbers, I have to find x and y. Now, I'm only gonna do one of them because they're done the same way, and you guys can figure that other one out on your own. So I need to know what 220 cosine and sine of 225 are. So I'm going to draw 225. Reference angles 45. Negative, negative, root 2. So 8 times negative 1 over root 2. Or 8 times negative root 2 over 2, since that's how we normally look at that number. So that's negative 4 root 2. And this one's going to be exactly the same thing. So my answer is negative 4 root 2 minus 4 root 2 I. That's the first number. Then you're gonna have to do the same exact thing here. That's 45, that's gonna be 4 root 2 plus 4 root 2 I. Now that we've got them both written up here, doesn't that make sense? I mean, think about it. How far apart are these numbers? 180 degrees. So if that one's negative, negative, and the third quadrant doesn't make sense, that one's gonna be positive, positive. Exactly 180 degrees across.
So
Okay.
just flip the negatives.
I wouldn't do that unless I'm sure in my mind that that's what's happening. Because it's not gonna happen with some other angle, but it will when you're 180 degrees apart, yes. Did you have a question?
It was 5.
Yeah, okay.
Could you do number 2 on homework 6.6?
I can. I wanna remind you that we have a test tomorrow, and we have a review sheet that probably we ought to be looking at some point. Okay, so which one am I doing?
Number 2, please.
Type it in on your calculator, sweetie. X is root 7 cosine 113. Y is root 7 sine 113. Just type it in.
See, when it, like, you can't find that one again.
113? If you're gonna do it by hand, it has to be a 30, 60, 45, or half of that, or double that. And 113 is none of those things. No, it's calculated wrong. Just type it in. You're gonna get decimals for that. All right, what else? Josh,
13 on the review sheet.
number 13. Remember that work is force times distance times cosine of angle between. All right, so what have I got? I have a force of 111 pounds, so that part's easy. Acting in the direction 5, 2, in moving an object 16 feet, so the distance is 16, from 0, 0 to a point in the first quadrant along the line y equals 3x. So, here is my distance. My distance is 16 feet. I'm not gonna worry about that, I already put that in there. But it's over 1 up 3. So, my object is moving along that line, okay? The force that's acting upon it is in the direction 5, 2, so it's over 5 up 2. So the object is moving on a vector that's over 1 up 3. Or over 2 up 6, it doesn't matter, that's the ratio. And the force is acting on it in the direction over 5 up 2. So I know that that vector is 16, I know this one is 111. All I don't know is what is the angle between them. So how do we find an angle between two vectors? Dot product. So, the dot product of these two vectors is 5 plus 6, so 11. X times X, Y times Y. And the dot product is also calculated by taking the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. So X times X plus Y times Y is one way of calculating dot product. The other way is magnitude of first times magnitude of second times cosine of angle between. So 11 over the square root of 290 is the cosine. And before you even type that in, let me remind you, Remember what we're doing over here? What did we need? We needed a force, we needed a distance, and then what do we need? Don't we need that number right there? So 11 divided by the square root of 290, and that, whatever that is, that's gonna be the answer to the question. Okay? All right, what else? Oh, we got time, let's get some more questions done. Julia? Mr. Shadio, didn't I do this one already? I didn't do this? It's familiar to me. Okay, so Mr. Shadio releases a ball 4 feet above the ground, da, 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 da. Now, let's write some parametric equations. That's the way we approached this, last time. The y part goes back to our projectile motion formula, because y gives me the height. So who remembers what that formula looks like? How does it start? Negative 16t squared, that's how it starts. Now, I'm gonna have something times t. And the something is going to be the vertical component, the y part of the vector that he threw the ball with. So what is that?
Wait, why wouldn't it be your initial velocity?
If I'm doing parametric, if I'm doing just the straight Cartesian, then yeah, that goes in there. But that formula does not take into account the 5 degrees. So I need to do this parametrically because it's not a vertical thing. Okay, so what's this gonna be? 66 sine, I'm doing y, 66 sine 5, and then plus 4. If we just use our plane, projectile motion formula, that velocity right there is the ball thrown straight up or down. You can use it for down too. That's not what's happening. So as soon as we put an angle in there, then we have to account for that angle. That's going to change some things. And so we'll do it parametrically, where the y component of the vector is this. And what's the x component of the vector? 66 cosine 5. Now these are the ones that are tricky when you type them in, because this parentheses is mandatory. Now this one will come in, so you're gonna have to put that one in and close it off. But you've gotta have that in parentheses, and likewise here. It won't work if you don't. Now, what are we looking for? After how many seconds after the ball is thrown will it hit the ground? How far from Mr. Shadday will the ball be when it hits the ground? So you're gonna draw a picture of this. Let's go ahead and do that quickly. We don't have a lot of time, but what do I have to do first? I gotta be in parametric mode, right? Alright, and then I gotta type in those equations. I always forget that second parentheses. I have no idea what my window is. Let's see. You need to be in degrees also. I'm not sure how you are, but you need to be in degrees. So let's make sure that you are.
anyone have a window that works?
I haven't got one yet, I'm still playing with it.
What do you mean? I got two.
I just got a
I should, why did, like 50, I mean X, like,
Trying to get.
Then we'll take the first one. Gotta balance.
Oh, I got it. I got one that works.
You got one that works, what you got?
I did, for X, I did -50 to
Oh my gosh.
50 to do 0. And then, or like 0 to 50. And then for my Y minimum, I just did like -3 and my max is 7. Random.
Just 7?
7.
Did you get,
Well, cause
Did you
it's
get a
falling
one?
down.
did you get a one that's on
Well,
the
it ends at 0.
Yeah.
7 is actually almost too big, isn't it?
Grab something for pride.
Not mess up.
I'll grab my cat, yeah, actually,
I don't know. I don't brush your hair.
Alright, so, yes, I did too. I got what she got, kinda like this. So the question is twofold. And I guess now that I think about it, I was using a Y that was too big. But it really, I don't want a very big Y because he only threw the ball, with an angle of 5 degrees. So that isn't a very big angle, so it didn't go very high. So that makes sense to me now that Maren gave it to us. All right, so now I'm going to trace. And I'm just,
How do you get it?
hit trace.
Right, but if I can't get it on 0.
Hey, you're getting close, we're estimating. So it looks like after about how many, what does it say? How many seconds after the ball is thrown will it hit the ground? Looks to me like it's about point, what? How many seconds?
Wouldn't X be your second?
Nope. Nope, X is your horizontal distance. T is your time, so it looks like about 0.35 seconds or something like that.
What?
0.
You're at like 0.65.
That's what
Oh,
well, that's what I,
Well, I'm like, the closest it'll let me get to Y being 0 is like a Y of 0.9.
Yes, about 0.7.
I must have the wrong
Actually,
equation.
don't even
That's the cheat.
Actually, don't even
Wait, you guys,
About 0.7.
Oh, you know what? My problem is I forgot to add the +4 on my equation.
why doesn't it let you get to 0?
Let me see what that changes. Okay, all right, so now let me try this again since I didn't,
You guys? He's surviving. Chugging along. Do you look lost still?
yeah,
You
so
see me- you see me-
it's about 0.9. No, it's about 0.6, 5 something, and it's about 43 feet away from him. Would you agree with that?
I don't. Go ahead, think about it.
So since we're not on it exactly, it can be a little bit iffy, but it's somewhere between 0.65 and 0.78. So we could say 0.7 seconds. And it's about 45 or so feet away from him when it hits. Tess?
So when you do second trace, what are you doing?
No, we're not second tracing, we're tracing. Trace. And then you can watch your cursor go up and come back down. See it?
When I got it, I still got this straight line going down. Is there something, like, is there a step change at all? Like, our two step, should that be changed?
I don't know. You'll just have to look at my window, look at my equation. All right, what else do we got? Come on, we only got a couple minutes here. What else do we have? No, why would you ask if you already know?
That's a
the
stupid
T-step.
question.
You know, for substance, you know, change the, you know,
It's the
feel the
T-step.
silence.
That's what
Can you do
changes it.
12 on your view sheet?
This one, we did one exactly like it in the homework.
Okay, but this is 2 and 5.
It is exactly the same, so let me show you why it's exactly the same. If we are solving for z, then what do we need to do?
Square root.
We need the square root, or we might think of that as raising to the 1/2 power. That immediately tells me that I am gonna have two answers, right? And they'll be 180 degrees apart from each other. So do you see how that's exactly like, I forget who asked this, but is that exactly the same as what we did before? Right, in the homework?
Yeah.
Okay. Leah,
Can we do 7G?
to find the fifth roots, okay, this is exactly the same thing, only we're finding fifth roots. So we're gonna raise this to the 1/5 power. Right number? So what does the Moab say? It's already in polar form, so it's already set up perfectly. What does the Moab say? 6 to the 1/5?
Yeah.
And 295 divided by 5, which is what?
59.
59. Okay, I don't know how I'm supposed to answer these. This says complex form, I guess it doesn't say, so we're gonna leave it that way. So that's my first answer. How many answers are there? 5. How many degrees apart will they be? They'll all be 6 to the 1/5, which is also the 5th through the 6th. It doesn't matter how you write it. But how far apart will they be?
72.
72. So this one's gonna be 131, and this one's gonna be 203, and this one's gonna be 275, and this one's gonna be 347. Now, I did that all in my head, probably made some mistakes. I'm gonna do one extra. If I go one more 72, I'll be at 419.
But you can do that.
But 419 is the same as 59, so I think I'm right. So those are my answers in polar form. If I needed them in complex form, I would need a calculator. And I would do the 5th through the 6th, or 6 to the 1/5, cosine 59, and that sine 59. And that would be my x plus yi number for each one of those.
When somebody's asking like for the direction angle of a vector.
Standard position. Standard position angle.
Okay.
So if the vector, I don't know, if the vector's poking out here, it would be this angle right here. That's the direction.
Okay.
Thank you.
All right, what else?
I'll share it.
Come on, time for one more, let's go. Lucy,
Can I ask a homework problem?
I don't care.
Alright, can I do number 4 on homework 6-4?
Find polar coordinates. So, if I am finding polar coordinates, what are these?
Cartesian.
That is right, so that's x and y. So here's my setup for that point. So what's my r? Number 5. I don't know that angle, so I'm gonna need a calculator. The directions tell me I am in radians, so I'm gonna set my calculator in radians, okay it is. And, I'll do second tangent 2. So this is 1.11, basically, that little reference angle there. So what is my actual theta? I plus that? So my actual theta is 4.25. Now, that is exactly how I'm gonna do every problem that says write in polar coordinates. I'm gonna draw my picture, I'm gonna find my R, I'm gonna find my theta. Then I'm gonna go back and make sure I've done it the way they want me to do it. For example, this one says R has to be positive and theta has to be between 0 and 6.28. Okay, it is, good. But sometimes they give me the exact same problem, but they'll say something like, let R be less than 0. Well, R is never gonna come out less than 0. It's always gonna come out positive. Then you're gonna have to artificially make it negative, if that's what it says. And when you make R negative, then you're gonna do what with that? Either add one, pi, or subtract pi. And in polar coordinates, it makes no difference. I'll probably just go back to my 1.11. I'll subtract pi from that. And these points are the same. This is what the directions on the homework wanted, but once in a while, they want something like this. And you have to manually change it.
Could you do number 3 on homework 6.3?
Okay, last one. We gotta wrap this up. So x equals 2 cosine t, y equals 2 sine t. So I'm gonna go ahead and I do without a calculator. So I'm gonna go ahead and change this into a rectangular equation. So I'm gonna square everything.
No.
So I have x squared over 4 equals cosine squared, and y squared over 4 equals sine squared. I add those together, so I get a circle with a radius of 2. So if I drew the whole circle with a radius of 2, that would be okay, except what do these directions say? You are only to go from 0 to pi, which is just this part of your circle. So that's what it is. All right, test tomorrow. Part calculator, part no calculator. What does the word exact mean? Some of you are still screwing up. No calculator. If you see a 60 in your problem, it's probably not supposed to be done on the calculator.